given the go-ahead. So, my name's Lucas. This is Adam. We're going to talk about how our take on something that has actually been talked about a lot here. There was a talk yesterday by the Lars guys, some stuff at DEF CON about this. This is our take on badge reading. We both work at a company called Crow Horwath. I am a manager in title only. I'm more of a pen tester and a code monkey, and not very good at the coding piece, but it works.
Yep. I'm senior consultant there, pen tester, Lucas's bitch. Do anything that comes up.
Thanks for that. So, if you want to get in touch with us, here it is. We'll have more later, but all of our code, our designs, we'll talk about that. It's all here. We'll have another slide later, but we wanted to give that to you now. So,
overview of what we're going to talk, a little bit of refresher if you haven't been to the Lars talk or anything recent on that. Talk a little bit about our physical access control systems that we've seen, what we're doing against them, our methodology. We'll get into our device here and the application that we wrote for it on mobile devices, as well as some mitigation, remediation, and then, of course, all of our lovely tools. Background here on RFID is that there are various forms of it, some low frequency, the high frequency, and the ultra high frequency. Low frequency is out there a lot because you can use it without license. There's no regulation on it. Anybody can use it. Anybody can create a device or technology against it. High frequency is where you kind of get into some proprietary applications where people are writing their own specific things that are locked down that have some sort of a protection against them. And then as well as the ultra high frequency used in massive supply chain tracking defense applications when you're shipping all your Xbox Ones or PS4s, whatever you're looking at there. Again, if you saw the Lars talk, low frequency is about 80% of the applications out there. Whenever you have a large market share, you're going to be attacked a lot. There's going to be people going for you because they want to try and gain something that everybody's using, so they don't have to keep going after the little guys over and over again. They can just make one stop, and they end up compromising a whole lot of the access. They're in education facilities, they're at schools, they're in government at buildings, they're at the water protection generation. They're in medical facilities, financial institutions, which is what we do a lot of. You see them everywhere. They're in shared corporate buildings in New York, government facilities, basically anywhere that has a need to protect something behind a door. Most likely they have the low frequency badges. The blank cards that we've used are the T5577s. They're readily available. You can get them from anywhere in China. Alibaba's got them all over the place. They will cost anywhere from 30 cents to $1 each, depending on how many you want to buy and what quantities and who you're talking to. They range and they hit the broad spectrum from all the way from the 26 bits all to any kind of bit coding that you want to do on any of the low frequency cards. So that's kind of why we chose these as our blank clones. How do the doors work? You scan your badge in and it beeps. A lot of times it just flashes red or yellow. You don't really know if it's authenticated or not. There are some doors that actually will flash the red if it's deactivated, but most users are just looking for that beep. So you can tail in and just do a badge that doesn't work, and most of the time they'll let you in. But if you are actually authenticated, what happens behind the lines? You see there's two lines there. Those are the data 1, data 0s. So when you swipe your card, it pulls the voltage on that reader, and it will send it back to the controller over the Wiegand protocol. There's some other ones out there, the RS-232 or some proprietary applications. However, Wiegand is the catch-all because it's it's easy to implement, cheap. You only need a couple wires there, 2 for the voltage and 2 for the power, to the back-end controller, which then does all of the authentication for the cards. It will actually unlock the interlock system once it's gotten the okay from the server and the back end. It will do all of the relocking of the door. And it does take the Wiegand protocol, translate it to whatever data network you have behind that, send it to the server, ask the server, this hexadecimal card, who is it, what is it, do I have access to the door, and it can do various zoning. And that's where the server then is mainly just your back-end application for users on giving them access, removing access, delegation, and then assigning them rights in various zones.
So, we talked a lot about Wiegand. I think it's important, and some of this got cut off, but it's important to actually know how this protocol works. There are a lot of other options that people have, RS-232 being another big one that you will see, but almost everybody uses Wiegand because it's simple. It requires 2 wires, and that's where most of the buildings were built. So you see this all over the place. We see it in everywhere we look and everywhere we go for clients. And the way it works is that there are 2 lines. They both have 5 volts at all times. And whenever you want to send a bit, you drop the requisite line down to 0 volts. So if you want to send a 1, you drop data 1 down. If you want to send a 0, you drop data 0. And that's how you send the information. So what we get, and the way Wiegand works, is it is in, obviously it's computers, so it's binary, and you will get, the controller just gets a long string of bits and does various things with them. You see this all the way up to the new I-class stuff. Obviously, it's sending a lot more information. Some of the older ones, it's just 26 bits. But that's what people are talking about when they talk about the length of the card, the length of the information that you're receiving. Now, there's a few things to note with this if you ever decide to build one of these things yourself, design something, or do anything along those lines. First, these are at 5 volts. You will occasionally see some tolerance on other things, but what happens is this is not, just like any other digital application at the hardware level, is not a situation where it's a raw drop all of a sudden. The voltage kind of peaks off. So what happens is a lot of times you'll have to build like a debouncing circuit. You'll have to do some things in software. And if you look at ours, you'll see that. We're lazy. We just put in a little timer because they shouldn't happen more than once every millisecond. But you have to do something to handle that because otherwise you may get multiple bits. The other thing that you'll find a lot that I know we had issues with this. We actually talked to the Lars guys yesterday. They had it in theirs as well. You have to make sure you're using a common ground because when you drop this down to 0, if you're using 2 different ground rails on your design, well, things are going to get weird and stuff's going to read all wrong and the bits aren't going to work and your cards aren't going to work and, well, you know, look like an idiot trying to badge into a door and nothing happens. So, for us, we talked about the methodology or the technology. Let's talk about our methodology. You guys, it was on our title. You're probably wondering why we sit in bathrooms for hours. We have. It's very effective. From our perspective, with the testing that we're doing, a lot of places are looking at how can I escalate up through physical access? How can I change the cards that I've got? And that stuff's really cool. But for the clients that we have, in the end, what we're trying to do is build a story. We're trying to be able to tell them, okay, you gave us a conference room to do a pen test. What's the real risk there? And of course you tell them, well, someone could have gotten a Trojan or spearphished or, users being the ever so intelligent people they are probably have given a lot of access. But for whatever reason, our clients like to think that they have that physical security piece. So they want that story of how did I get into the building? So for us, all we'll do is we will look at just getting through the front door and from there putting a NUC, a pwn plug, something like that on the network so that we can continue our testing. We are not really doing a lot of things with changing facility codes and user codes and other things. So instead, for us, it's all about finding the right target, just so we can get in the door. Half the time, users are dumb, so they'll let us in, or the receptionist just gives us a conference room, and we have our success with social engineering. But we do have a few clients that have really stepped up their game, and that's why we kind of had to step up ours, and that's when Adam had this idea, and we started working on this. So we have the reader. We need to find somebody. So a lot of times we'll, hang out in the hallway if it's a shared building, see if we can find someone. We've had a, few weird instances where you're following somebody thinking they're going to lunch and you spend 20 minutes following them and it turns out they're going home. And so you have to turn around and go back to the client. But, for us, I think the best is, patience. So we had a guy that's a member of our team actually spent about 4 hours, 5 hours sitting in a bathroom stall the entire day. And so he had this thing, which we'll show you in a minute, and he was just holding it up against right above. He had it kind of propped on the top of the toilet paper. And as people would come in, sit down, he'd take their badge. If he didn't get a badge read, he'd get up and go wash his hands and wait for him and kind of, twist the thing in the bag a little bit to see if he could get it. He left at the end of the day with only like 5 or 6 badges, but it ended up that one of them worked and it got him in. So for us, it really comes down to let's get that, let's get in, and leave something. So we use Proxmark as well to clone badges just like everybody else does. And If we have to, we will start brute forcing sequential IDs. We'll make multiple cards. But our goal is to just get 4 or 5 cards. You know, sometimes we'll follow people out to lunch and get more. That's always fun. We also actually, we took this to DEF CON and got like 60 or 70 cards just walking around there for the 2 days. We just walked, 2 miles in New York City once and pulled
about 50 or 60 cards in a 6-block radius.
So these things are effective. They work really well. Especially the longer distance stuff, you can get 2 or 3 feet of reads. You know, there's been a lot of talks about that, so we're not going to...
You be careful turning the gain up too high, because then you start to get a little false positives with your hex that's coming in.
So, from our perspective, when we started looking at this, there's a lot of cool stuff people have done, right? The Lars guys, Bishop Fox, several others. If you look for stuff online, you will find a lot of great information. But what we wanted to do is do something that was easily repeatable. So a hobby of mine is hardware design. So what we did is we actually took a lot of the other things that people have done. We used a very common platform in Arduino, and we developed a board. And we developed a board that's supposed to be easy to assemble. So the other thing is it's very modular. It supports a lot of different output types. You can do LCDs, both colored and non-colored. You can do Bluetooth low energy. You can do you know, an SD card, all that sort of stuff. Now the other thing that we found is it's really annoying when you're pulling cards. And yeah, if you're sitting in a bathroom stall, you can kind of pull stuff out and see if you're getting things. But if you're just wandering down the street, it gets a little odd when you're beeping. So what we have done is we actually put together an iPhone app that listens over Bluetooth low energy, vibrates in your pocket. When you get a card, you can actually go in and look at them all, see as things are coming in. Additionally, the board uses entirely through-hole components. It's easy to solder. There's a lot of space on there. We kind of built and designed it with the whole idea of repeatability in mind. And we actually have put up, if you're familiar with the PCB Fab OSH Park, we actually have a project there as well. It's public, it's shared. We have a link so that you can go on. You can get 3 of these boards made for about $18, $17, which is actually well worth the money instead of trying to do it yourself and etch it. And it's just spend the money. So you can't, for those that are in the back, we thought we'd put a picture up. This is our board. Yeah, this is what the inside looks like. The LCD, obviously it's a little superfluous given that it's inside, but it helps for debugging. We put it in there just in the event that someone wanted to cut a hole in or do something like that. It's supported. We use SD cards, and then as I said, we use Bluetooth a lot. So we also elected to use a much larger battery. A lot of the designs you will see online, they use a lot of double A's, triple A's. It takes a lot to get up to the 14 volts or so you need to drive the actual reader. Now, the nice thing there is they provide a nice common voltage. So with some of these lithium polymer batteries, the voltage will vary. So what we've actually done is built in just it's a linear voltage regulator and a couple capacitors to build just a real basic power supply so that you can use these much bigger batteries.
Something that would last longer than 20 or 25 minutes. So ours can actually last for about 12 hours, 16 hours. It'll last for however long you need it to be because it is quite literally a laptop external battery.
Yeah, we actually have no idea how long it lasts because it's never run out on us in a test, which is nice. So we can wander around all day. So what we thought we'd do is do a quick demo here, show you all exactly how this works. And since I'm guessing all of you don't want to crowd around and look at the iPhone, we thought we'd do it here. So we have our app. You connect to the device.
See how many people have Bluetooth on?
Oh, not that many. I turned it on earlier, and there were like 50 or 60 devices in here. So you connect. We are successfully connected.
Take your badge, and as you're just walking by somebody,
shows up. And you couldn't see it or you couldn't hear it, but it actually vibrates too. So you can put this in your pocket. And sometimes you get really excited, and it turns out you just got a bunch of email, and that kind of sucks. but the rest of it, it's good. Now the other thing that you can do is we actually have it so that then you got to get this out, right? It'd be a pain to have to type it, so you can email it to yourself. And now, obviously, got to be careful. This is, email, and it's incredibly encrypted, right? So think first, maybe before sending a lot of client information around. But it is something to consider.
It's always nice from a documentation standpoint if you need to prove something to a client, or if you need to put something in a work paper, some type of report that you're doing, you can have that nice out there so you don't have to type all the ones and zeros out yourself.
Right. So, for mitigation, this is always a big piece. And the truth of the matter is mitigating this is tough. When we talk with our clients, they'll ask us, well, what can we do? How can we defend against this? I'm like, well, you can get the guy that owns your building to spend a couple $1 million and re-architect everything, because that's going to happen. So there's a bunch of pieces of this. You can protect the badges. You can put them in the sleeves. You know, users, being the wonderful people that they are, I'm sure really love having to pull that in and out every time. So that may or may not be effective. We need to do some user education. And this comes around not just for how to protect your badge, put it in your pocket, don't let us see the IDs, don't let us catch them, but also making sure that people are actually verifying people that they don't know and don't recognize. You can do multi-factor, but if you've seen any of the other talks around this, it turns out that a lot of the multi-factor information, like PIN codes and other things, are stored on the card. Since we all know client-side controls are, you know, wonderful, perfect things, it seems like a bright idea. The other option is you can go to newer badge systems. They're not perfect either. In fact, the keys for a lot of the high frequency stuff are all publicly available, or you can get apps from China and other things that'll give you all of that. And it's expensive. And what you find a lot of times, I don't think we have a single client with all the people that we've worked with each year that actually own and manage their badge system. For them, it's usually the building owns it, the building manages it. So that's also a big challenge for folks. So what can you do? It really comes down to making sure users know how to protect systems. So here are the links. Here's how to get in touch with us. All of the Arduino PCB stuff, it's all online. It's all in Fritzings, so that's open source. You can get it. You can also go to OSH Park at this link and immediately order the boards, and they will come. So we are at time, but if you guys have any questions, please let us know.
Source code for the app for the iPhone is actually on the GitHub page. If you want to clone it, if you have a dev account, we're working on getting it actually published in the App Store. But in the meantime, that you don't want to wait for that, you can pull it down, compile it yourself, and load it into your iPhone.
And be gentle. We're not iPhone developers.